Hello everyone, in this video I am going to talk about statistical data analysis. Here we conduct various types of statistical method such as descriptive and inferential statistics to analyze the data and get some meaningful insights from it. So first of all, what I am going to do, I will be going to load my dataset. So I am going to click on here, click on upload, and I am going to load my Titanic dataset. Now, the first thing that I'm going to talk about is descriptive statistics. So there are two types of descriptive statistics we have. First of all, we have measure of central tendency, which is mean, median, mode, and then we have measure of spread, which is variance, covariance, skewness, kurtosis, etc. So we will talk each one by one. So let us first start with loading the dataset. So first thing that I'm going to do is I am going to import my pandas library. So import pandas as PD. Next, I am going to load my Titanic dataset. So I am writing df equal to pd.read_csv. And here my dataset name. So my dataset name is titanic.csv. Now, with the help of head function, we are going to see top 5 rows of the dataset. So df.head function. Now this is my dataset. Next, I am going to check the shape of the dataset. So my dataset contains 891 rows and 12 columns in it. Let me print all my column name with the help of df.columns. So these are all my column names. Now I am going to check the data type of each column name. So for that purpose, I am going to use something called as df.dtypes function. So here we can see we have integer column, we have object column, as well as we have float column also. Now what I am going to do, I will be going to perform descriptive statistics. So let me give it a heading. So first thing that I'm going to talk about is something called as measure of central tendency. So let us implement measure of central tendency, which is mean, median and mode. Measure of central tendency. Now I'm going to calculate the mean of the element. So mean is basically taking the average of all the elements. So first thing that I'm going to do is selecting my data frame name, then my column name, which is fair. After that, I am using mean function in order to calculate the mean. So the average fair value is 32.20. So this is my mean. Next, what I am going to do, I am going to calculate something called as median. So let us understand what do you mean by median. Median is basically the middle number on the sorted list of number. So here we can see we have numbers given here. What is the middle number here? Which is 6. So 6 will be considered as the median. Similarly, here we can see the number is given. What is the median here? So the middle numbers are 4 and 5. So what we will do, I will take the average. 4 plus 5 divided by 2, which is 4.5. So this will be our median. Now how to implement this thing? First of all, you have to specify your data frame name, then your column name, which is fair, then median function. So this is my median value of fair, which is 14.45. Now I am going to talk about mode. Mode means the most frequent value. So it is applied on the categorical column. So let us take any categorical column here. For example, I am going to take 6 and I am going to find which is the most frequent value in 6. So for that purpose, I am going to write df.6.mode. Then I am going to take the most frequent value. So here we can see The most frequent value in 6th column is male. So this is all about measure of central tendency. Now let us talk about measure of spread. So the first thing that I am going to talk about is variance. Let us understand what is variance. Variance is basically the average of square differences from the mean. Here is the formula for calculating variance in a population and in a sample. So variance equal to summation of xi, which is your population, minus mu. Mu is basically your mean divided by number of sample. Similarly, here n minus 1. Now, what I am going to do, I am going to take an example and let us clear this thing. So here, let us say if the return of stock in a company ABC are 10% in first year, 20% in second year, and minus 15% in third year. So first of all, what we will do, we will be going to calculate the average of all these three, which is 5%. Next, I am going to calculate the difference between each return. So here we can see difference between each return is 5%, 15%, and minus 20%. Now what I am going to do, I am going to take square of this all three, which is 0.25%, 2.25%, and 4%, which is 6.5%. Then I will divide by n minus 1, which is 3 minus 1, which is 3.25%. So this is our final answer, which is the variance. Now let us implement this thing programmatically. So first of all, I am going to calculate the variance of fare. So what I will do, I will write like df dot fare dot variance. So this is how you calculate variance for fare. Next, I am going to talk about standard deviation. So let me give a heading, standard deviation. So first of all, let us understand what do you mean by standard deviation. So it is a measure of how spread out numbers are. So this is the formula for calculating our standard deviation, which is xi, which is the value of ith point in the data set, minus the mean value of the data set divided by n minus 1 and then square root. So let us understand with the help of an example. Suppose that we have a number given 5, 7, 3, 7 and we want to find standard deviation. So first of all, I am going to calculate the mean, which is 5.5. So my mean is 5.5 and the number of samples are 4. Next, what I am going to do, I am going to find the variance. So variance is basically subtracting the mean from the each data point, then squaring those values. So here 5 minus average value is 5.5, which will be going to this and so on. After that, we will square all those values and divide by n minus 1, which will be going to 3.67. Then I am going to take the square root, which will be 1.915, which is our standard deviation. So you can say that standard deviation is basically the square root of the variance. Now, how do we calculate this thing? So first of all, you have to write your data frame name, then your column name, which is fare. After that, you have to apply STD. STD means standard deviation. Now run this out and you will get our value, which is 49.69, which is basically the square root of our variance. Next, I am going to talk about range. So range is basically maximum minus minimum. So first of all, we will be going to calculate maximum value. So df dot fare dot maximum, then minus df dot fare dot minimum. So the result will be our range, which is going to be 512.32. Next, I am going to talk about something called as interquartile range, which is IQR. Let us understand what do you mean by interquartile range. So here we can see this is the diagram of box plot. So interquartile range is basically your third quartile, which is Q3 minus Q1. Let us understand with the help of an example. So here we can see the numbers are given to us. We will divide the number into two parts. The first one will be called as lower half and the second one we call it as upper half. After that, I am going to calculate the median, which is 53 plus 55 divided by 2. Then we are going to calculate Q1, which is our 52. And then we are going to calculate our Q3, which is 58. Then we subtract these two and we will get our interquartile range. So this is how you calculate interquartile range. In Python, you can do it very simply just by writing df dot fair dot quantile 0.75, which is our third quartile, minus the first quartile, which is 0.25. And this will give you interquartile range, which is 23.08. In Python, there is a method called as describe, which you can use to perform the descriptive statistics. So if you do df.describe directly, it will calculate for all the columns and everything. So here we can see, we can get count, mean, standard deviation, minimum, maximum, and first quartile, second quartile, and third quartile. So this is the benefit of using describe function. Now let us talk about covariance. Covariance is basically a measure of how much two random numbers vary together. So this is the formula for calculating the population covariance, which is value at ith data point minus average. Similarly, value at y data point minus average divided by n. Let us take an example. Here we have given two numbers x and y. So there are total number of observation, which is 6, which is the count of x, mean of x, which is 17.67, mean of y 25.5, and after that we are going to calculate the covariance. In Python, we can implement covariance with the help of NumPy library. So let me import NumPy library. Then I'm going to use np.covariance df.column name, which is fair. Let me calculate the covariance. So here the covariance will be 2469. Next, let us talk about skewness. It tells us how much data is skewed. So in order to visualize it, you can use histogram. So first of all, I am writing import cborn as sns dot histplot, then my column name, which is df dot fair. Then I'm going to title histogram of fair column. Then I'm going to show the histogram. Here we can see the PLT library is not defined. So what I'm going to do, I'm just going to define this thing. So this is my histogram for the fair column. Now if you want to calculate the value numerically, what you have to do, you have to write like this: df dot column name, which is fair, dot skew. So this is my skewness. Here you can see all the values are on the left hand side. It means it is having a right skewed distribution. Similarly, you can calculate the kurtosis. Kurtosis basically represent the fatness of the tail. So kurtosis df dot column name dot curt. So by applying this formula, you can calculate the kurtosis of a column, which is 33.39. Let us talk about something called as normalization and standardization. Suppose that we have the data points given to us. Now in order to perform normalization, we are going to use this formula, which is x minus x mean divided by x max minus x mean. Now the output will be in the range 0 to 1. In standardization, what happened? We apply this formula, which is x minus mu by sigma. Sigma is basically our standard deviation and mu is basically our mean. Now this result in the range of minus 1 to 1. So this is the difference between normalization as well as standardization. Here the output is in the range of 0 to 1 and here the output is in the range of minus 1 to 1. You can implement the normalization with the help of sklearn library. So what I'm going to do, I'm going to use sklearn.preprocessing module and import the min-max scalar function. Then I'm going to initialize min-max scalar function. Let us apply normalization on the fair column. So df fair normalize equal to scalar dot fit underscore transform. After that, we are going to specify our column value, which is df fair. Now let me run this out. Now here we can see our data is being normalized. Let us check the value here. Now here you can see all the values is in the range of 0 to 1. So this is basically our normalization. Let us talk about standardization. In standardization, what we will be going to do, we will be going to use something called as standard scalar. So from sklearn.preprocessing, import standard scalar. Then I'm going to initialize our standard scalar. Then I'm going to implement the same thing here. But the only difference will be our column limb. So it is fair. Standardized. Now let us print the standardized value. And here you can see it is in the range of -1 to 1. So this is how you perform normalization as well as standardization on a numerical column. So this is all about descriptive statistics in Python programming.